Okay, so today we are going to be solving polynomials, which is just building off what we've been doing the last couple classes. So solving polynomials, so just like solving quadratics, we are looking for the solutions of x. So solutions of x, that's what we're trying to find. And to do so, we need to put our polynomial in factored form. So let's do that, put it in factored form. And we know how to put polynomials in factored form. We know how to do that with synthetic division. But before we get to solving polynomials, I want to do a quick review of solving quadratics. So, this first quadratic, the first thing we can do, which is easiest, is to see if we can factor it. So, is there any two things that add to 6 but multiply to 2? So, the only things that multiply to 2 are 1 and 2, but those don't add to 6, so it's not factorable. So, since it's not factorable, how do I solve this quadratic? Well, we solve it with the quadratic formula, okay? And so that's the quadratic formula right there. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So, do we remember where a, b, and c come from? So, standard form of a quadratic is ax squared plus bx plus c. So, a is the coefficient in front of x squared, b is the coefficient in front of x, and c is the constant on the quadratic. Okay? So, that's where those numbers come from. So, you remember in the quadratic formula, there's no x's, just numbers. So, we're going to have x is equal to negative b. What's my b value? 6 is my b value. So we'll have 6 squared, okay, minus 4 times a. What's my a value? Well, there's no number in front of x squared, so it's a 1. So 1, and then c value is 2. All over 2 times a, so 1. So now we just need to simplify it. Okay? So we have negative 6 plus or minus the square root of 36 minus 8 all over 2. So that equals negative 6 plus or minus the square root of 28 over 2. Now, can we simplify this? So, you know how to simplify square roots from last year, okay? What do we do to simplify this? Because if you put that into the calculator, it doesn't take the square root nicely. Okay, do you remember your factor trees? All right, 28. What are two things that go into 28, right? We need to break it down into its factors. So the two things, since 28's even, we can say 2 and 14, and then 7 and 2. Okay, so what we really have is negative 6 plus or minus 2 times 2 times 7. And do we remember what to do after this? We're wanting to group our numbers. Since there's no number in front, it's like there's a 2, so I want a group of 2. And what do I do with that group of 2? I bring that number to the outside. So it's negative 6 times 2, and what's left? The 7. Okay? So I can times these together. Sorry, this plus or minus. sorry, I don't times those together. I need to have a plus or minus on there. Because it was negative 6 plus or minus 2, square root of 7, all over 2. Okay, last thing, can I simplify even further? Well, this is one term, this is one term, and they're all divided by 2. Is there something that goes into 6? Or can we divide 6 by 2? And 2 square root of 7 by 2? Yeah, we can. Okay. So, go up here, and we can get negative 3 plus or minus the square root of 7. And that's what x equals. Okay, that's 2 solutions. We'll get practice on it. So, I know we haven't spent time going over simplifying these. So, if you gave me this as your answer, I will accept that. If on the test you can simplify these, I will give you a bonus point if you do, okay? So we'll practice simplifying these as we go forward because I think a few of these you need to be simplified. So don't worry too much if it's kind of hard and you don't remember how to simplify. I'll accept the non-simplified answer on the test, but if you simplify, you'll get bonus points, okay? So try to practice today. So those are my 2 answers, okay? Let's look at the next one. So I want you to try to solve this one because it's just review. You know how to solve the quadratic formula. So pause the video and then try to solve it and we'll go over it. Okay, now that you all had a chance to try to solve it, let's go over it. So plugging everything in, x is equal to negative b, so negative, and then our b is negative 12, plus or minus the square root, the square root of b squared, so negative 12 squared, minus 4ac, all over 2a. Okay, now let's just simplify this. So x equals, and a negative times a negative is a positive. So we got positive 12 plus or minus 144. And then negative 4 times 2 times negative 5. We get positive 40 all over 4. Okay, so now we can just keep simplifying. We go 144 plus 40. We get x is equal to 12 plus or minus the square root of 184 all over 4. Okay, now remember, I would accept that as your answers, but if you want a bonus point on the test, you have to simplify this even further. So we got to say what goes into the square root of 184. Sorry. Okay, what goes into the square root of, or what goes into 84? Let's try to split it up. Well, since it's even, we can do 2. So 184 divided by 2 gets me 92, and 2 can go into that. Gets me 46. 2 and 23. Okay. So any groups? Well, we have a group of 2. Okay, so sorry. Okay, group of 2. So that comes on the outside. So remember, on the outside I had x is equal to 12 plus or minus 2. And then what's left is 2 times 23, which goes back to 46. Okay. all over 4. So can we simplify that a little bit further? Yes, we can. So I get x is equal to, and 2 goes into all of those, so I get 6 plus or minus the square root of 46 all over 2. Okay. So those are solving with the quadratic formula. That was just a quick review of how to do it because we're going to be using the quadratic formula going forward. Okay. Now let's look at question 3. Well, actually, before we get to question 3, I want us to go on the back page and quickly review solving polynomials in that flow chart. Okay. Just to review what to do when we're solving polynomials, because it's kind of steps. You need to ask yourself questions. Do I do this? Or ask yourself questions to know what to do next. So the very first thing, even before we factor or anything, what do we always need to look for? The GCF. So we need to ask ourselves that question. Is there a GCF? Okay. So if there is a GCF, pull it out. Okay, now we go to the next step and we ask ourselves, is it a quadratic? Okay. If it's not a quadratic, what do we do to factor? So if it's a cubic or a quartic, how do we factor those? Well, we factor using the rational root theorem. So use the rational root theorem. Okay, so use the rational root theorem to find all possible roots. And then, do we remember what to do after that? Use synthetic division to test and factor those roots out. Okay, and then we write it, once we find something that works, we write our new polynomial in factored form. Okay, now that we have it in factored form, we go back and ask ourselves again. So we need to ask ourselves, is it a quadratic? Okay, if it is a quadratic, we factor. If it's not a quadratic, then we go back and we repeat synthetic division until we get it down to a quadratic. So actually, I'm going to write quadratic here again, sorry. And then if it is a quadratic, we need to solve the quadratic. So, or sorry, we need to factor it. Can we factor it? So we can ask ourselves that, sorry. So can we factor? If we can't, what do we do if we can't factor our quadratic? We use the quadratic formula. To solve for x. And if we can factor, then factor to solve for x. After we've either used the quadratic formula or factored, so write out all solutions for x. Okay? So let's just quick review. Always look for a GCF. Okay, if there is a GCF, take it out. Now, after we've taken it out, ask ourselves, is there a quadratic left? No, then we have to use the rational root theorem and use synthetic division. If it is a quadratic, then we can go down to factoring. Can we factor that quadratic? No, we have to use the quadratic formula. Yes, we can factor, okay? So these are just the questions you need to ask yourself. Pretty much constantly ask yourself, either is this a quadratic or can I factor this? Okay, so let's go back to that page and look at question 3. What was the very first thing we have to do to solve for x? Or yes, to solve for x. GCF. Is there a GCF in question 3? Yes, there is a GCF. We can take out 2x. That's my GCF, 2x. So if I'm factoring out a GCF, it means I'm dividing each of these by 2x. So I get x squared minus 6x plus 3 equals 0. Okay, next question to ask ourselves, is this a quadratic? Yes, it is a quadratic. Can I factor this quadratic? Well, let's see. So, right, two things that add up to -6, two things that multiply to 3. Is there anything? Oh, sorry, that shouldn't be a 3. I was thinking the 6 beforehand. You're probably like, what the heck? So it's 9. Okay, 9. Sorry. So, is there two things that add to -6 and multiply to 9? Yes, there is. -3 and -3. So, I can factor it. Okay, we can't forget this 2x that we already factored out. And can I use the shortcut? Yes, because there's only a 1 in front for my a value. So I have x minus 3 equals 0. So what does x equal? X equals 3, right? They both give me the same answer. X also equals something else. So remember that x we took out? That gives us an answer of 0. Okay? So do we remember how to get solutions? We need to make each of these equal to 0. So I'm adding 3, and that's how I get x equals 3. And with 2x, putting it to 0, well, if I divide by 2, it just gives me x equals 0. So those are my two solutions, okay? So let's try, I want you to try this next one, and then we'll go over it, but I just want you to try it. So you can pause it here. Okay, so now that you've tried it, the first thing you should have asked yourself is there a GCF? Is there a GCF? Yes, there is. It's x. So we factor out x. Okay, and then now, do we have a quadratic? Yes, we have a quadratic. Can we factor this quadratic? Well, let's see. Find two things that add to 7, two things that multiply to 10. Well, that's -2 and -5. Can I use my shortcut method? Yes, because the a value is 1. So we can't forget about that x. But I have x minus 2, x minus 5 equals 0. So what does x equal? X equals 2, x equals 5, and remember this x we factored out gives us 0. So we should have 3 solutions. Okay, let's go to, I'm going to skip 5 because we already solved a bunch of quadratics already. So let's go to 6. Okay, looking at question 6. Is there a GCF? Yes, there is a GCF. What is it? It's 3, right? It's not x, because does 9 have an x? No, but they all have 3, so we can take out a 3. So I got x cubed plus 6x squared plus 10x plus 3. And the nice thing about taking a GCF out, even though it doesn't have an x, it makes all our numbers smaller. So it makes going forward easier. Okay, do I have a quadratic? No, I do not have a quadratic. So what do I have to do if I do not have a quadratic? I have to find all my possible roots. So remember, all my possible roots are in the form of p over q, positive and negative. So what was p again? It was all possible factors of our constant. So what are the factors of 3? Well, just 1 and 3. Okay, and what goes on the bottom? What is q? All the possible factors of our leading coefficient, so 1. Okay, this makes it a lot easier. Our possible roots are 1 over 1, which is just 1. And we have to have the positive and negative, and 3. Okay, so nice and easy. So let's just start with 1 and see if it works. That's right, we have to test these out with synthetic division. So let's start with my synthetic division. I'm using 1 first, so what goes inside? Well, I can use these, because this is where I got my possible roots from, so I need to use those coefficients. So 1, 6, 10, and 3. Now, just as a hint, you can kind of tell 1's not going to work because none of these have negatives, so we're never going to end up subtracting numbers. We're going to keep getting bigger. So you'll see in a second. 1, so remember we dropped down the first one. 1 times 1 equals 1, and we add those two rows together, so 6 plus 1 is 7. 1 times 7 is 7, so we get 17. 1 times 7, 17, so we get 20. So that's not going to work. So we need to try a negative number. So let's try negative 1. So bring down the 1. 1 times negative 1 is negative 1, so I get 5. Then I get negative 5. Right, 1 times negative 5 is negative 5. Add those together, I get 5. 1 times negative 5 is negative 5. Negative 2. That doesn't work. Okay, let's try negative 3. 1, 6, 10, 3. Negative 3 times 1, negative 3. So I get positive 3. Positive 3, negative 3 times 3 is negative 9, so I get positive 1. Then negative 3 times 1 is negative 3. Does negative 3 work? Yes. Okay, so let's go back over here and let's write our new factored form polynomial. So we said negative 3 works, but do I write it as x minus 3? No, remember I need to switch the sign. Okay, so I'm left with, remember these give me my coefficients. So I have x squared plus 3x plus 1. Okay. Now, am I left with the quadratic? Yes. Is that quadratic factorable? Well, let's see. Is there anything that adds to 3 but multiplies to negative 1 or to positive 1? No, because the only things that multiply to 1 are 1. So if we can't factor it, what do we have to do? We have to use a quadratic formula. So x is equal to negative b, so negative 3, plus or minus the square root of b squared minus 4ac all over 2a. So this one has smaller numbers, so it's not too crazy. So we're going to have negative 3 plus or minus 9 minus 4 all over 2. So negative 3 plus or minus the square root of 5 all over 2. Now, can I simplify 5 at all? No. So that's my answer. I can't go any further. So let's write out all the solutions for x. So x equals, and it helps if we go back to our factored form, okay? Well, we know x is equal to negative 3 We did that. We did synthetic division to find that. And x also equals -3 plus or minus the square root of 5 over 2. It's not a nice answer, but that is a solution of x. So those are my answers. Okay. So I want you to try question 7. So we'll pause the video, use your notes to help you, but I want you to just try it first because we've gone over everything. I just want you to try it to see what you can do. It's okay if you don't get it right, and then we'll go over it. So I'll pause the video. Okay, so first thing we always ask ourselves, is there a GCF? Yes, there is a GCF. We can take out 4x. So if I take out 4x, I'm left with x squared minus 3x plus 10, all equals 0. Okay, so question, is this factorable? Is there two things that multiply to 10 but add to -3? Well, the only things that add to 10 are either 1 and 10, or multiply to 10, or 1 and 10, and 5 and 2, and they have to be the same sign. So that doesn't work. Okay. So it is not factorable. So what do we have to do? We have to use our quadratic formula. X is equal to -b. So -3 plus or minus the square root of b squared. So -3 squared minus 4ac all over 2a. And again, let's simplify it. X equals 3 plus or minus 9 minus 40 okay, over 2. So x is equal to 3 plus or minus the square root of -31 over 2. Okay. So I'm just going to leave this here because next class is when we're going to talk about answers with I in it. Okay, so we're just going to kind of leave this here. So this is our solution, and what else is our solution? X equals 0. Okay. Let's quickly do question 8. It's not too hard, and then we'll be done. Okay. Question 8. Is there a GCF? Yes, it's x. So I factor out an x. I got x to the 3 minus 8 equals 0. Now, I know it's not a quadratic, but do you recognize anything about it? Can I factor it? Yes, I can. It is a difference of cubes. So you remember this formula? A cubed minus b cubed equals a minus b, a squared plus ab plus b squared. Okay. So we'll just use that. So we got x, and then we have, what's b? Is b 8? No, it's 2. Okay, so we have our b value is 2. Sorry, hold on one second. Okay, so let's fill in those numbers in our formula. So we have x minus 2, and then we have x squared minus 2x plus 4. Okay, Now that we have a quadratic, is that factorable? Is there two things that add to -2 but multiply to 4? No. So what do we have to do? Our quadratic formula. Okay. So x is equal to -b. So -2 plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to 4 plus or minus the square root of 4 minus 16. That actually turned into an arrow. All over 2. So we get 4 plus or minus the square root of -12 over 2. And again, we'll leave it like this because we'll practice with negatives and getting complex answers in a little bit. So our answers are x equals 0, x equals 2, and x equals 4 plus or minus the square root of -2 over 2. And like I said, the reason we're not simplifying this is because of the negative underneath, and that's what we're going to do next class. We'll review that. Sorry, this wasn't the greatest video. I am looking after 2 babies, so it's a little distracting. If you have any questions, we'll be spending some more time doing this when I get back. So don't worry if you don't get it yet. But good luck, and I will see you on Friday.